So last we're going to take a look at applications of voltage, or basically what we can do by applying voltage and some of the different devices that we've been able to create using electric potential. Now, one of the most important devices that we probably don't even realize exists out there is the electrostatic precipitator. What is that? Well, during the combustion of most fossil fuels, if you don't get 100% complete combustion, where you're turning the hydrocarbons into all carbon dioxide and water, you get soot. You get these carbon products which produce particles that can be very, very unhealthful to people, especially who have asthma. And what these electrostatic precipitators do is you take the exhaust from some type of furnace, something else that's going to generate this incomplete combustion, and you put it through this device, and the device is basically these grids of high voltage. The air flows through this, becomes ionized due to the high voltage, and then the ions transfer their charge to the dust particles, and the dust particles will stick to the charged grid. So it is a very, very important device in removing pollutants, especially from fossil fuel plants, where you're generating a lot of energy, you're consuming a lot of these hydrocarbons, and again, by passing it through these grids, we can literally pull them out of the air and reduce the pollution. Here you can see the operation of a furnace connected to one of these electrostatic precipitators when the precipitator is on, and here you can see when the precipitator is off, and there's a very stark difference between the two. In the first case, there's no visible emissions. In the second case, clearly there are aerosol particles coming out of it. Now, it doesn't reduce the amount of carbon dioxide, so we're still introducing greenhouse gases, but at least it removes the dangerous particles that can lead to different respiratory conditions and illnesses. You can actually have a version of this in your home. This is known as an electrostatic air cleaner. In this case, this is more helpful for people with allergies. It'll take dust, which can be dander, pollen, a lot of different other things that is in the air in the home, and using these high voltages, charge the air, and then use collecting grids at a different voltage to pull these particles off. So they're very, very effective in removing particles from the air. One downside of this is that they actually generate a little bit of ozone in this process, and that can be irritating, especially for people who do have asthma. So usually they recommend a HEPA filter rather than an electrostatic filter for home. But you can actually eliminate most of the ozone by humidifying the air afterward too. Another application was developed by Xerox. When I was an undergraduate, I actually took a course from one of the professors who was partially responsible for the development of this. And Xerography, which is a trademark name from Xerox, what they figured out how to do is take a semi-metal, which is known as selenium, and selenium, when it is exposed to light, becomes conductive. When it's not exposed to light, it's actually non-conductive. It changes state. So what happens here is you take the image of something that you want to duplicate and then shine that onto the selenium drum. So wherever there's light, that part of the drum will become conductive and pull the charge away. So the first process is you charge the whole drum, which is selenium. It's in its non-metallic state. You expose it to light, turning that part of the drum into a metal, conducting the charge away, because we know that conductors can conduct charge, leaving the non-conducting part still charged. That will then take up negatively charged toner. The negatively charged toner is then impressed onto a piece of paper, and using high pressure and heat, it can be embedded into the paper. So very, very useful application here of voltage. Again, the high voltage is used to charge the selenium drum, and then the charge is used to pick up the toner particles. Of course, this is also used on a laser printer. A laser printer, instead of taking the image of something that's going to be copied, the laser printer actually draws the image onto a piece of paper, and wherever you have a light area, the laser is going to convert the selenium back into a metal, leaving all the dark spaces to be the charged areas to pick up the toner. And again, this has been a laser printer. Really, they became popular when diode lasers became cheap and easily controlled by computers. Colored laser printers, the concept's not all that different from the regular laser printer. Color printers also work the same way. Instead of a single black drum, you actually have 4 drums. The black drum for light and dark, yellow, magenta and cyan as the different colors, and these inks when put together can create any color. And basically the idea, let's go back there. The idea behind this is you take 4 different images, or you draw 4 different images onto the different laser drums, because you have 4 different drums, and then if everything is lined up properly, you get one nice color image from this. Inkjet printers are an inexpensive type of printer. They also use voltage, and the way that it works is you have this ink jet which will basically spray ink droplets through this charged electrode. It'll then be deflected by this parallel plate capacitor, and whenever you want it to draw, it'll simply send these different colored jets toward the paper. If you don't want something there, it'll deflect it using these plates and then recollect the ink to be reused again. Again, like the color printer, you're usually starting with 4 to 5 different jets. You know, sometimes 2 jets for black, then your cyan, magenta, and yellow. And here's sort of an illustration of how that works. And again, this one's using 4 different inks: black, cyan, magenta, and yellow.